This is AP Calculus AB for response question 6 for 2010. So with this problem, we're given solutions to the differential equation dy over dx equals x y to the cubed. Also satisfy second derivative equals y cubed times 1 plus 3x squared y squared. Let y equals f of x. Let y equal f of x be a particular solution to the differential equation dy over dx equals xy cubed, with f of 1 being 2. For part A, states write an equation for the line tangent to the graph of y equals f of x at x equals 1. So obviously we are already given 2 points. F1 equals 2. So we know that information from the problem. It's already stated. Now in order to write an equation of the tangent line, we need to have 2 points, and we also need to know our slope. Which slope equals derivative. So we have our first derivative here. So all we need to do is just plug in our points, which are given on the problem. So 2 cubed, which is 8. So our slope is 8. So from there, just simply use the formula. Substitute. And there is our equation. For part B, it states use the tangent line equation from part A to approximate f of 1.1. Given that f of x is greater than 0 for interval from 1 to 1.1, is the approximation for f of 1.1 greater than or less than f of 1.1? Explain your reasoning. So basically here, what we need to do is we're going to plug in 1.1 to our tangent line. So just simplify. So it's going to be 2.8. So basically, since y equals f of x greater than 0 on the interval that is given on the problem, our second derivative, which is also given on the problem, is greater than 0 on that interval. Therefore, on the interval from 1 to 1.1, the line tangent to the graph of y equals f of x at x1 will lie below the curve, and the approximation 2.8 is less than f of 1.1. Cut it. For part C, it asks to find a particular solution y equals f of x with the initial condition f of 1 equals 2. Now in the problem, we're already told let y equals f of x be a particular solution of the differential equation dy over dx equals xy cubed with f of 1 equals 2. So we are going to be using this function, or derivative. So the first step to finding a particular solution is going to be to separate what's given to us in the problem. We need to separate our variables. So since it's asking for f of x, we don't have f of x. So we need to undo the derivative in order to get our f of x. So the first step is going to be to separate our variables. So we're going to multiply by 1 over y cubed. Whatever you do one side, you do the other. Now for this part, we're going to multiply by dx in order to get it to the other side, to x. So we are left with 1 over y cubed dy equals x dx. Now here, we are going to integrate in order to undo our derivative and figure out our f of x. So this is going to be x squared over 2, let's see, this is going to be negative 1 over 2y squared. Now, we are also given our points in the problem, which is 1 and 2. So in order to find the particular solution, we need to figure out for our c. So right here, simply just plug in your points. So our y is 2, our x is 1, simplify, 2 squared is 4, 4 times 2 is 8, 1 half, let's see, common denominators. So our c, just simply subtract to isolate c, that's going to be negative 5 over 8. So now that we have our c, we plug that back into our original derivative and solve in respect to y. Our c, substitute, because now we know that value. Now we need to isolate y, so the first thing we're going to do is multiply by 2. X squared over 2 minus 10 over 8. Simplify. Reduce. 10 divided by 2 is 5, divided by 8 is 4. 8 divided by 2 is 4. Then multiply by y squared. Equals square minus 5 over 4. Y squared, then isolate y squared, divide by x squared minus 5 over 4. So you want to be careful with your signs. Right here I'm simply just going to rewrite. Then also I'm going to be multiplying by 4, the numerator and the denominator, to get rid of the fraction because that's annoying. So 4, 5 minus 4x squared equals y squared, and then the final step is just to square root, and our particular solution is 2 over radical 5 minus 4x squared.